First, you want to write it horizontally. Okay. So we are going to do 1 divided by x squared minus 3x plus 2 plus 1 over x minus 2. Write your division horizontally. What's the reason for that? It's easier for us to attack just one set of quantities at a time. Now, if you look at this, would you agree we can do the first set of quantities? Yeah, so just do one at a time. So let's do it. What do we do on the first set of quantity? Factor, you're right. Go ahead and take 1 quick minute to get a head start on that factoring. Once you have your factors, I need you to compare that with your team, and then I'm going to shuffle your card so I can call on you. Brandon, whenever you're ready, what are the factors of x squared minus 3x plus 2? X plus 1 times x plus 2. Do you agree with Brandon? No. Why not? Very good. Okay. So that would be x minus 1 times a quantity of x minus 2. What do we do next? On LCD, y'all, what is the LCD for that first set of quantity? X minus 2 times a quantity of? Perfect. Do we need to do anything at all for that first fraction? Nope. Copy it down. 1 over x minus 1 times x minus 2. Do we need to do anything for the second fraction? Yes. What are we going to multiply to the denominator? X minus 1. What we multiply to the denominator, we must multiply to the top. 1 times x minus 1 is x minus 1. Now, denominators are exactly the same. So, what do we do with the numerator? Just add them. There's only one x, so I'm going to copy it down. What's 1 minus 1? 0. So, I am done with that quantity. Would you guys agree? Let's move on to the second quantity. Similarly, what do we do? Factor. Can I factor x squared minus 1? Good. What are the factors? Good. All right. Now we need to find the lowest common denominator, which is what? X plus 1 times. Good. Then we will do the same thing. We do not need to change anything at all for that first fraction on this set of quantity. What are we going to multiply on that second fraction over here? X minus 1. Good. Whatever we multiply to the denominator, we must multiply to the numerator. So what do we get now on the numerator? Good. X minus 1. So now divided by. Denominators are identical. What do we do with the top? Add it. How many x's do we have? 1. Do we have any constant? Nope. Now what? Box it up, call it a day, take a nap? No. We multiply by the reciprocal. But before we do that, we should state the? Yep. For this one, would you agree that this side x can never ever be? Okay, on this side too. You guys want to do both sides at the same time? Okay, so this one is positive 2 and 1. Is that okay? Now we can flip. So x all over x minus 1 times x minus 2 multiplied by the reciprocal. So now this is on the bottom. Now box that up. No? Simplify. By the way, should I say this restriction? This x can never ever be what? 0. Can we cross out the what? And then this x. Final answer. What do we have? X plus 1, all divided by x minus 2. Box that up. Let's put all restrictions all in one place. X cannot be, tell me, plus or minus 1, comma, 2, comma. Perfect. I'm going to leave that up so you can copy that. And then we have one last example, example quattro. Okay, so this one, can you guys see that it's already written horizontally for us? Yeah, we don't even have to rewrite it. So first things first, what's the LCD for the first quantity? 24. Okay, so this one, we go 24 minus something 24. It looks like my computer's is acting up. Okay, so here we go. What do we multiply to this first numerator? 3. So that's 3x. Oh, well, you know what? It's not wanting to do. Oh, there's 3. 3x. It's not working. Okay. It's a delaying process at this moment in time. Okay. All right. Over there, I know some of you said 8y, but my computer is not allowing me to write, so it takes a minute. Okay, there you go. Then, can I just go both at the same time? Would that be okay with all of us? No. No? Okay, we'll do one at a time. Then, this first set of quantity. Okay, so I can just add the top. 3x minus 8y all over. Over what? 24. All right. That's as far as we can go. Do we need to state the restriction here? No, because 24 is in the denominator. Is that 0? No. Can we ever get 0 from that? No, because it's a real number. Now, on the right side, what's a common denominator? Also 24. Okay. So I don't need to do anything with that first fraction. I'm just going to copy 5x over. But the second fraction? Okay. My computer is a little bit delayed, so I'm writing it, but it won't process until like now. Okay. Then we will divide it by. Can we do anything else now? 3. Okay, 5x plus 3y over 24. 5x plus 3y all over 24. Can I simplify? Can I do anything? Now I can need to flip before I can, yep. 3x minus 8y all over 24 multiply by 24 all over 5x plus 3y. Now we can reduce 24. But again, do we need to state the restriction with this cancellation? No. So I'm just going to cross it out. Then we multiply horizontally. So what do we get on the numerator? Good. 3x minus 8y all over 5x plus 3y. Can we factor out anything to cancel? No. So we box it up. But one thing that's a little bit different with this class is the restriction. Okay. Can you see the denominator has 2 different variables? So, and we still take the denominator and we still set it equal to 0. So here's where we have choices. Because we only have one equation and 2 variables, all we do is solve for one of the variables, and you don't have to, you can pick either one. So let's say that I've decided to solve for x. Okay, that means I'm moving 3y to the other side. So this is 5x equals negative 3y. Divide both sides by 5. So that means x can never, ever be negative 3/5 of y. That's all we write with the exclusions. If you decide, to solve for y, that's okay too. Then you can just move the 5x over. Then divide both sides by 3. Then you can say that y could never, ever be negative 5/3 of x. Do you have to do both? No, you pick one and then you decide. Now, this right here tells me that I can pick any y I want. Would you agree? Then that means x can't be that amount of y. This over here, you can pick any x you want, and y just cannot be that amount of x. Okay? That's an egg roll.